Now we're going to take a look at properties of logs. All of these properties relate to properties of exponents because the log is an inverse of an exponent. They might seem a little opposite of the properties that you're used to working with for exponents. And again, it's because the log is the inverse. So let's take a look at the first one. When we have log of multiplication, we can turn it into addition of logs. So think about it this way with our properties of exponents. If we have x squared times x cubed, we add the exponents together. Remember, the answer of a log is the exponent. So that's why it works. We're adding the exponents together when we add the logs together. And it came from multiplication. For a similar reason, if we have a log of division, we can change it to subtraction of logs. Again, if we have x to the fifth divided by x cubed, we subtract the exponents. So the division turns into subtraction. The last one is the power rule. And what that does is it takes the power and it multiplies it by the log. It becomes a coefficient. So this is related to our power rule of exponents. If we have x squared cubed, we multiply the powers together, x to the sixth. So remember, the answer of a log is an exponent. So this is an exponent, and we multiplied it by an exponent. So all of these rules make sense if we remember our properties of exponents. They just work a little bit differently. So we're going to start by using these properties to expand each expression. So we have log of multiplication, so we expand it to addition of logs. So we have log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. The next thing I notice is that middle log has a power. So I'm going to use our power rule to pull that down as a coefficient. The other two logs will stay the same. So again, that 3 as the power on x becomes a coefficient of my log. So now we have an expression that is fully expanded. Next one, we've got natural log of the square root of y. Now this one seems like it's as expanded as it can be. However, remember that the square root is a power of 1/2. So we can pull that power in front of the natural log of y. Part C, we have division and power. I recommend splitting up the division first and then using your power rule. Otherwise, you will most likely lose the distribution of that power. So I'm going to split this up as natural log of x to the 1/4 minus natural log of y to the 1/4. They were both under the 1/4 root, so I converted the 1/4 root to a 1/4 power as I split the division to subtraction. Then we can use our power rule. 1/4 times the natural log of x minus 1/4 times the natural log of y. Again, you can expand this with the power rule first, but you would need to keep your natural log of x minus natural log of y in parentheses so that you could end up distributing that 1/4 power. This one we've got a lot of stuff going on. I'm going to expand the multiplication and the division at the same time. So it becomes log of x to the 4th power plus log of y to the 7th power. That piece in the denominator gets subtracted, so we have minus log of z squared. Then we can use our power rule on each piece and pull that exponent out as a coefficient. 4 times the log of x plus 7 times the log of y minus 2 times the log of z.